Screencast is on. All right, so here's what we're going to talk about. First, the peer grading for this week. We've collected all of your homework and made it available again. However, we haven't, by we I mean John, hasn't yet written the grading guidelines. Okay, they simply aren't written. So if you click on the link to the grading guidelines in the instructions, you'll just get a directory that doesn't really have any interesting content yet. So that means two things. One, you can't really grade your peers' homework, but you can look at it. And two, if you have any suggestions about what the grading guidelines might say, you could tell John, and you might take those into account. So that's that. Also, there's a new homework assignment which is available. It has 5 problems. 3 of the problems have a PDF, basically a 1 or 2 page PDF file. And what you have to do is use LATEX, which is what we're going to learn about today and Wednesday and Friday, to create a PDF file that looks the same as what's there. And it just uses some basic LaTeX stuff. Okay, so you'll know you're right when your LaTeX file looks like the PDF file it's given. That's the first 3 problems. The 4th problem, a very arrogant mathematician has written some document. So what we do is we wrote a 1-page document with some statements and theorems in it. And then we just went through and introduced a couple of errors in the logic. And so you just have to fix them to get the thing to compile again and look decent. So that's the 4th problem. I think, yeah, it's the 4th problem. The 5th problem is to just come up with a nice example of a LaTeX document. Search around online, just find something really cool that you can do in LaTeX, like draw a cool picture, or if you like music, maybe show musical notation, something like that. Purely, you'll get a perfect score on that problem if you put in any effort. It's just for fun, okay? So that's the homework assignment, which is already available and due on Friday. Also a reminder, I won't be here on Friday, but somebody else, Jaya Devarethra, will be here. Okay, so that's that. Second, so I was meeting with some guy right before class on Friday, and then suddenly SMC started not working right, and I didn't know why. So I started looking into it, and then class started. And then as you may have noticed in class on Friday, SMC didn't work perfectly. In fact, some people for a little while couldn't even load the page. You literally refresh and nothing would happen, which is something I've never seen before, ever. That's never once happened with SMC where you just couldn't even load the landing page. It turned out that there was a massive distributed denial of service attack against SMC that started at about, these times are in Europe time, but started just before noon on Friday and then ended around 5 or 6 p.m. And so what happened, it was a WordPress amplification attack where somebody tricks a large number of WordPress sites into sending packets asking for acknowledgement from another website, namely in this case, cloud.sagemath.com. Then that website ends up getting literally millions of requests over a very short period of time saying, acknowledge me. And then it tries to respond to them and it completely overloads the kernel of the operating system and things crash. And just to give you a sense of the bandwidth, so at some points you're getting well over 300 megabytes of data per second that was incoming from all these sites. And we looked in the logs, and the stuff that actually got through, it was all these WordPress header type things in the HTTP logs. So that was annoying. I spent the weekend setting up Cloudflare, which basically, so there are a bunch of servers that SageMath Cloud runs on with various IP addresses. And it used to be that anybody could figure out what those addresses are and then send traffic to SageMath Cloud. Now what happens is that there's a site called Cloudflare. It's a whole bunch of computers, maybe 70 or 80 computers and data centers around the world. Now when somebody tries to connect to SageMath Cloud, the IP address they get is some machine at Cloudflare. And then Cloudflare then proxies the traffic to SageMath Cloud. And the IP addresses will change. And if Cloudflare thinks that that traffic is bad for some reason, it matches some signature of some sort of attack, Cloudflare will just not forward the traffic on. And also the IP addresses of the SageMath Cloud servers, which I changed, are not known publicly anymore. So,
let's say as of this weekend.
What? Yeah, I made all these changes live Sunday morning. However, the process of putting this caching and defense layer around SageMath Cloud, given how complicated SMC is as an application using all kinds of new stuff like WebSockets is complicated and leads to subtleties. For example, when we were preparing for class today, making the homework assignments, we noticed that the PDF files weren't updating because Cloudflare was caching the PDF files that LaTeX generating. So we had to disable that caching. So there's subtleties like that. Cloudflare has a list of file types where it caches them for at least 4 hours. So for example, a Cloudflare website has a button I can click, which will change it so that anybody who tries to go to the SageMath Cloud website has to do a CAPTCHA first. I mean, and that's something you can do if you're under attack. And so if millions of WordPress hits are trying to get through, you click that button, and then suddenly they're all just completely denied before it ever gets to SageMath Cloud. So in case you're curious, at least what happened last Friday shouldn't take down SageMath Cloud in the future. Somebody would have to work much, much harder. Yes?
Do you know if that's like an intentional attack or?
I don't know what or who. I did not receive a ransom letter, which is typically what happens with these sorts of things. I mean, if you look, there's a couple of reasons some people will do this. One is just to demonstrate their capabilities. 2 is they want to extort money from you. 3, they don't like some content that you have on your site, and they want to make sure it isn't visible. Like, I guess maybe China doesn't like that GitHub hosts certain content. So China just takes down certain content at GitHub by denial of service attacks. Or they just personally have some problem with your site. There are people that may have a problem with SageMath Cloud. It was abused a lot by Bitcoin miners, and I was constantly in battle with them for a while, but I won. I mean, by just basically shutting off network access. It's not really useful for Bitcoin, and other sort of stuff. People have tried to launch successfully denial of service attacks from SageMath Cloud, and we shut off the ability to do that as well. So maybe somebody was annoyed by that. I don't know. So I have no idea what the reason is, but it should be much, much harder to do this in the future. Okay, so now LaTeX. And this file that I'm showing you right now, you'll find, so one of the things about the LaTeX editor in SageMath Cloud, really LaTeX editors in general, there's a lot of auxiliary files that they kind of just swear all over the place. So if you look in the thing for today, you'll see that there's the PDF I'm showing you, the text file that creates it, and then there's an image, namely the traffic that I just showed you, and then a whole bunch of other files, which are auto-generated as part of the LaTeXing process. Most of them are grayed out because, I mean, you don't really want to see them. Some of them aren't grayed out because when Nick and John were implementing the grayed out stuff, they didn't realize that there were these types as well. So they need to be added to that list of files that get grayed out. So if you're trying to look at this, just click on the PDF file. Okay, so more about LaTeX. TeX itself was a system that Donald Knuth at Stanford wrote long ago and over many, many years. And the goal was to make it so he could typeset the books he was writing. So he wrote this huge sequence of books called The Art of Computer Programming, and he wanted to typeset them so that they looked really good. And when he started writing them long, long ago, the way people would write books is they'd write them out by hand, and then a secretary or somebody would type them with a typewriter, and then maybe put formulas in by hand. It was just really tedious. And that's, in fact, how math papers got written for a long time. Like it used to be, if you looked at a math PhD thesis, there would be a big acknowledgement to whatever secretary in the math department actually typed up the thesis and did all the math stuff in there. And all the old math from the 70s or earlier looks horrible to look at because it's all typeset, all funny, and it's all kind of ugly. So he decided to change things, and he wrote a professional quality typesetting system aimed at highly technical math-oriented documents. So that's what TeX is. And then other people have added a lot of functionality on top of it, like an absolutely enormous amount of packages, probably thousands and thousands of packages that make it so you can typeset all kinds of things using LaTeX. And at least in mathematics, it's the standard. Like almost every paper and every book in mathematics, at the research level at least, is written using LaTeX. And the American Math Society puts a lot of resources behind it and so on. It's completely open source and free. So you can install it pretty easily anywhere, hopefully, or maybe not anywhere. It's really big, so it's not something like you don't install it on your phone. I don't know if there's any way to use it that way, and it uses up a lot of disk space, well over a gigabyte of disk space. Nonetheless, it is something you could definitely install on your laptop or desktop. And there's many different ways of doing so. Also, there are a couple of cloud-based solutions for LaTeX. There's Sage Math Cloud, which has a LaTeX editor, which is what we'll be using, which I originally wrote specifically for the version of this class from 3 years ago so that I could talk about LaTeX for a week. And then people do like it. There's also some competitors. There's something called Share LaTeX, and it's another collaborative online LaTeX editor, kind of like Sage Math Cloud's. Better in some ways now and less better in other ways. Okay, so there's that. So that's the background. And now what we're going to do, so I have 3 tutorials, and we're just going to do them, and then various people who know LaTeX. Does anyone here know LaTeX already? Like you just know it really well? Enough to help other people? Well, when you're comfortable with like having done one of these things, the stuff here, seeing how to use it in Sage Math Cloud, if you know LaTeX already, I would greatly appreciate it if you just walked around and saw what other sort of problems people are having and then just answered them. Okay? Yeah, so if you know LaTeX already and you try this stuff, just get up and help people. So what we're going to do, I'll just kind of discuss what these are really quickly, and then we're just going to stop and you're going to actually do it yourself. We're going to create a new blank LaTeX document. For that, you click the plus new button, and then there's a thing for LaTeX document. What?
Does it matter where we create it at this point?
You can put it in your project anywhere you want it all, but you might want to put it in the one for today. And there's going to be a whole bunch of auxiliary files that just pop up there. You can put it in your Scratch directory, anywhere you want. So then edit it. You can change it. There's like a little tiny template default that appears there when you make the new LaTeX document, and you can edit it. And you should see to the right the compiled version. And then find some math and just paste it in so that you actually have some content in your LaTeX document. And then try out things like forward and inverse search and making errors and seeing what happens, downloading the PDF that's generated by LaTeX, and building and seeing the LaTeX. Okay, that's what the first one is. I might just do this really quickly in front of you, and then you'll try it out. The second one is to try pasting in and then changing slightly several math formulas. Inside of LaTeX itself, you can write big books, articles with all kinds of cross-referencing, with bibliographies, with sections, subsections, sub-subsections. Like it has a lot of structure to it. The documents are very structured, just like HTML documents, where you have headings and subheadings and so on. But also another feature of LaTeX is it lets you typeset mathematical formulas. And this is what the language looks like for typesetting mathematical formulas. I think if you just try out some of these examples and just try to make a few changes, you'll quickly get a feeling for how it works, even though you don't know all the details. Okay? And so this exercise, you'll just try pasting each of these into your LaTeX document, seeing what they look like, and changing them a little bit. And the last thing is to try out sagetex. And to do that, you put use package sagetex in the preamble of your LaTeX document, that is at the top. And then you try typing this, so in $signs, that. And what you'll find is it'll say 2018 equals question mark first, and then you wait a little while and it'll run Sage, and then it'll replace it by the actual factorization of 2018. So you can live do coding. Sage will get run automatically as part of the process of creating the document. Okay, and then once that works, you can try this link, which if you open this PDF, you should be able to click on right here, or you can just Google for sagetex documentation. And it has pages and pages and pages about sagetex with lots of examples about how to do things like drawing plots and so on. Okay, so the one thing I'm going to do in front of you is very quickly I'll show you some of this first tutorial, and then you'll just start doing stuff. So here we are. Okay, I'm going to click New, and then I'll just click LaTeX Document. And you've done this step before, at least once or twice in class, when we were just going through and looking at lots of different documents. So what happens is on the left you have the document, on the right you have the preview of that document, and you can make changes. So I'll do blah blah and blah 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 because I want to be very fast since I want you to spend time doing this. Whenever you save, it'll spend a little time, compile the document, and then update this over here. If you're at a given point over here, like this, if you then click on forward, it takes you to the corresponding point in the document. On the other hand, if you're in the document and you double click here, it should take you to the point that generated that. So when you click on some text, it'll take you to that point over here. So that's what the forward and inverse search stuff is. And downloading the PDF, that's this link right here. Download the PDF. This is a thing that Cloudflare may not work earlier today, but should work right now. The errors, if you make an error like 2 to the power of and nothing, so this is something that LaTeX will probably be unhappy about. Actually, LaTeX is okay with that. Oh, no, there's an error. You'll get a red issues button, and then you click on that, and it will show you an issue, missing $ inserted. And you can click there, and it takes you to the point where there's an issue. LaTeX, by the way, the error messages can be extremely frustrating to understand and fix. So if you feel really frustrated when you get an error, like in red right there, and you click and you're like, what the heck, this error doesn't seem to have anything to do with what I just did. I don't know what's happening. You're not alone. John, was I swearing at LaTeX an hour ago? So yeah, I mean, I think it's very annoying the way it works. It's hard to find errors, sorry. However, I do have a clever idea, I think. I'm curious what you think about it. I haven't implemented this yet, but every time you save your document to build it, SageMath Cloud knows the exact state of the document when you saved it. So if it works, then it suddenly doesn't work. It should just show you exactly what you changed. And then you would know what you broke. Because very often with LaTeX, it just says tech capacity exceeded or some crazy stuff here. So hopefully I'll implement that really soon because it shouldn't be that hard. But I don't know when it'll happen. By the way, so under the hood, just one thing that isn't in there. That if you click on the build button, notice there's this command line that gets run. It's this thing right here. This is what actually gets run to compile the document. And then what's displayed here is the output. And if you click on the, say, the LaTeX button, it will show you again what gets run. You can also create a terminal. And in the terminal, you can type the same thing. You can paste what was there. And it will run LaTeX. A bunch of stuff is just going to fly by when I do this. And you see the errors. So it's very similar to, so secretly behind the scenes, it's just running this one command right here. By the way, this is one of the main differences between SageMath Cloud and all of the other online LaTeX environments. All the other ones, they don't give you a terminal where you can just run any code you want and completely customize what happens. That's the unique thing about SageMath Cloud's online LaTeX environment. Okay, so that's everything. Now, all I want you to do for the rest of the time is these 3 tutorials, as I, and hopefully other people, will help you with, okay? So your goal is just going to be to have a LaTeX document that you're editing right now, okay? So go.